Z-scores. Z-scores are used to compare two sets of data to make a determination. For instance, I took an ACT and an SAT. On the ACT, I had a score of 31, with a mean of 21, and a standard deviation of 6. On my SAT, I had a score of 660. The test had a mean of 500 and a standard deviation of 100. Well, which test did I score better on? It's the one with the higher Z-score. So let's see why that's true. We'll be working with data with a normal distribution. It creates a bell-shaped curve when we plot the data. 99.7% of the data will fall within plus or minus 3 standard deviations. Remember, a Z-score is how many standard deviations the data element is from the mean. The mean has a Z-score of 0. If the Z-score is positive, it's above the mean. If the Z-score is negative, it's below the mean. Example 1. A teacher gave a quiz. The following stem and leaf plot shows the scores of the students in her class. The quiz scores had 140, 250s, 360s, 470s, 380s, 290s, and 100. The mean score of this data is 70, and the standard deviation is 15.8. So which scores are within one standard deviation of the mean? Well, as you remember, when we calculated the standard deviation, we took the square root of the variance. And anytime we take the square root of a number, we have plus or minus. So, to be within one standard deviation, we needed to start with our mean of 70 and add 15.8 and subtract 15.8. So the scores between 54.2 and 85.8 fall within one standard deviation of the mean. So that would include all the 60s, all the 70s, and all the 80s. A way to represent that with an interval would look like this. The lowest score, 54.2, is less than or equal to x, which is less than or equal to 85.8. Example 2. A data set has a mean of 16.5 and a standard deviation of 3. The element x has a z-score of 1.5. In which interval does the element lie? So let's go ahead and plot our scores. Our mean is 16.5. One standard deviation, we add 3 to give us 19.5. We add 3, 22.5. We add 3, 25.5. That's 1, 2, 3 standard deviations above the mean. To get the 3 standard deviations below the mean, we start at 16.5, subtract 3, subtract 3, subtract 3. So our element x has a z-score of 1.5. So if we go down here, we recall that our mean has a z-score of 0. 1 positive standard deviation, 2 positive standard deviations. So our z-score is between 1 and 2 standard deviations, or between 19 and 22.5. So this would be our answer. We could also find the data element by using our z-score formula. Our z-score is 1.5, which is equal to our data element, which we're going to solve for, minus mu, which is 16.5, divided by our standard deviation of 3. So go ahead and solve for x. So x, or our data element, is equal to 21. And as we can see, it does fall in our range of 19.5 to 22.5, because the z-score is 1.5. Example 3. The data set has a mean of 34 and a standard deviation of 4.5. An element in the data set has a score of negative 1.2. Without doing a calculation, state whether the element is less than, equal to, or greater than 34. So 34 is our mean. It has a z-score of 0. The element we're looking for has a z-score of negative 1.2. So that's somewhere here. below the mean. So the element is less than 34. And we can verify that by using our z-score formula. We have a z-score of negative 1.2, which is equal to our data element minus minus our mean of 34 divided by our standard deviation of 4.5. So go ahead and solve for x. So x is 28.6, which is below our mean of 34. So we're going to write the intervals for a normal distribution with a mean of 7 and a standard deviation of 2. So go ahead and label your graph. And you're going to be putting your lowest and highest for each interval. So go ahead and write less than or equal to x, which is less than for all of those. And look at example 1 and 2 if you're not sure what the interval should look like. So these are our intervals. The weights of cattle at the fair this year were normally distributed with a mean of 800 pounds and a standard deviation of 65 pounds. What is the range of cattle weights that fall within one standard deviation of the mean? Go ahead and try that. So to be within one standard deviation of the mean, we add 65 and we subtract 65 from our mean of 800. To represent it as an interval, we would write 735 is less than or equal to x, which is less than 865. The length of hair of a private in the Marines is normally distributed with a mean of 1 centimeter and a standard deviation of 0.3 centimeters. Private Workman's hair has a z-score of 2. How long is his hair? Private McLeod's hair has a z-score of negative 1.8. How long is his hair? And who needs a haircut? So go ahead and calculate the length of each private's hair. The number of crackers in a box of Cracker Box crackers is normally distributed with a mean of 75 and a standard deviation of 2. Mrs. Finnegan wants a box with exactly 82 crackers. What is the z-score? Go ahead and calculate. So z-scores. So back to my ACT and SAT dilemma. Which tests did I do better on? Well, by calculating the z-score for each test, I can compare them. And the test with the higher z-score is the one I did better on.